got the recorder up and running, and so let's go ahead and get started. And usually I just go with start with some topics that are not directly related, just so that some people can come in a little bit late and not miss too much stuff. The first one that I found, since last time we met, this has been coming for a while. It's not really exactly news. These are phones running Ubuntu natively. So it's interesting in a way, but I think they will run up against one particular obstacle, which is they are not Android compatible. So all the Android apps cannot run on these particular phones, but they can run a lot of open source projects natively, which is good in a way because those are native applications, which means they run at a much higher efficiency compared to Android apps. So it'll be interesting to see the adoption rate of these phones and whether they will keep making these or not. A lot will depend on the development tools available to these phones, because I think it's the apps that sell phones. The phones do not sell themselves. It's the apps that sell phones. So it'll be interesting to see how these phones stack up against iOS and also Android. I don't think these phones will compete with Windows phones at all. It's definitely entirely different type of clientele. So it'll be kind of interesting to see. Yep.
Do you think it's possible Google would, make an app for, using apps on Ubuntu?
They're already talking about that. Some of the apps, quote-unquote apps, will be browser-based. So they'll be running, JavaScript type of apps inside a browser, but it will be hosted locally. In other words, the page, the quote-unquote page itself, doesn't have to be on a server. And as long as it is a page that is stored locally, that can be an interesting type of app engine. Because that type of app engine has two things that is really good about it. One is it is definitely web ready, right? Because it's running in a browser. And then the second thing is a browser is universal to all mobile devices. So it'll be interesting to see how it goes. In this case, World Cup soccer and robotics. This one is kind of interesting. It's not really quite what you think initially, which is, we'll have robots, playing soccer. That's not really the case. If you go to the web page here, it will show you a military robot. So it's a robot for keeping an eye on the soccer fans and troublemakers. According to the specification of this robot, if you read more about this, it's about 40 pounds, so it's fairly small and light for a robot, and it can survive a 2-meter drop onto concrete, falling downstairs and being thrown into a window. So it's a pretty little hardy, robust robot, and it just makes me wonder why they need this kind of robot in a soccer competition. Sorry? Well, I think it's there to keep an eye on security, so they can patrol the parking lot and whatnot. So it's interesting why they need to deploy military robots basically in a soccer game. And for those of you who are really interested in having robots to play soccer, this is a link to the same website but a different article that talks about a robot that actually plays soccer. But not only that, these robots can also learn in the process. So it can learn on the fly, in the process of playing soccer. I haven't read the actual detail about it yet, but it's interesting. And also they play. This is the name of the conference called Shanghai, but except it's instead of just Shanghai, they turn the AI, the last two letters of Shanghai, into AI in uppercase, which is artificial intelligence. So it turns out to be also a conference of artificial intelligence that is hosted in Shanghai. So that's interesting. AI or artificial intelligence is coming back. When I was in graduate school, that was kind of like the tail end of the last AI era. And none of my advisors, in the AI field got tenured as a result, because people were not interested in AI at all at that point. And now it seems like people are interested in AI again. And I think it's probably due to the processing power that we have now, and Watson is the other reason. I mean, just IBM demonstrating what they can do with Watson certainly sparks the interest of AI again.
Isn't NSA developing like a quantum computer as well?
Sorry about that.
That's okay. Go ahead.
Wasn't the NSA developing a quantum computer as well?
I think Google bought one, but a lot of people argue whether it really truly is a quantum computer or not. Quantum computers are definitely still in its infancy, and when they do become available, it will change computer science, from its foundation. Because a lot of theories that we have currently about computers are basically restricted to non-quantum type of computers. Once we have quantum computers, it will change the basic theories of computation, all completely, basically. Okay, all right. So those are just little things that I found, and now would be a good time to get started with the actual lecture. Yep.
Can you go over again, the nest statements?
Go over what again?
The nest statements again, because I tried doing it yesterday and I couldn't figure it out.
Okay. Okay, I can give you some clues as to how to get it started. And let's take a look. The best way to get it started, I think, is to draw a picture first. Start with a picture. So let's, yep, go ahead.
I think one of the hardest parts about the homework, though, is just the example that's in your text is, you have your statement and then you have like an assignment, like a value that's assigned to the variable, but this one goes into an if-then, and I don't know if anyone else having this trouble, but figuring out how to follow it
Okay.
is very difficult. There's no example on how to do that, and I just don't know which line to go on or how that works.
Okay, just hold on a second. Let me get the document going first. All right, so this is your homework assignment. It looks like a mess because the first thing you have to do is to do the indentations. So are there any questions about adding indentation to the program? Is that part okay?
I don't know how to do
No.
that. I just don't know how to do that because it has.
I don't think the example you gave us shows that wording.
Yeah, the example doesn't really. It's not really like. Well, it is like it, but it's not. I don't know.
Like you have ifs, and in our example, it was just like while. You know what I
It
mean?
doesn't have both of them in there.
But it doesn't change the concept of having a statement inside another statement. See, that's the thing, about, having a statement inside a statement. It doesn't really matter what type of statement is inside what type of statement, because you're still having a block that inside the block is another type of statement, or statements, an entire sequence of statements. So instead of doing this homework assignment, I can give you another example. Okay, so hopefully this new one would help. Okay, so, all right. So let's go ahead and start with a new program that I'm gonna, try to do here. And can you guys tell me exactly which element of this program makes it kind of difficult?
There's not two whiles, like I guess within our example, so I'm not sure where the second statement is.
Okay, all right, go ahead.
Oh, and then what the part that I had difficulty with was that on line 4 there is if then, and then after that on line 6 there would be if then.
Yes.
And there's only one else on line 9. So
Yes.
I was confused about that one because can we have one if and not the other part?
You can have an if without the else, because that basically just tells you there's nothing to do with the else. So you can have an if statement without an else.
So the else is like a placeholder kind of.
And else is just catching what if the condition is not true. So if you have a conditional statement that only has an if but not an else, it means it doesn't have anything to do when the condition is not true. Okay. Let me go back to the notes and see if I can find it. It could be missing entirely, but I will go ahead and check. All right, so anyone find out whether there's a conditional statement without the else in the notes?
No, I have the notes.
Okay.
They're here. I even finished the one from the notes when I went home. I just couldn't do the homework. Do you want it?
I just want to find out whether I talked about a conditional statement without the else part.
This doesn't have else in it at all.
Oh, okay. And that's the homework, right?
No, this isn't the homework. This is what you did.
But it doesn't have an if either.
That's what I'm saying. That's why I don't
Right.
get why the if is there.
Well, the if is there because that's just the way I structure the program. I can put a conditional statement inside the loop, put a loop inside the conditional statement, and then put another loop on top of that. It does not matter. It's just having a folder inside a folder. It doesn't matter what kind of a folder you have inside another folder. Yep.
Things in the diagram sense, is it like when you sectioned off each side and each box had another box inside? Is that what the else would be?
Okay. First of all, let me just go over this part first. Okay, this is the part where right here. Okay, so let me just first give you this part here. Okay. Okay, this is a very typical structure or template of a conditional statement. It starts with if, it has an else, it has an and if. The purpose of the else is there to separate block 1 from block 2. BLK1 is block 1 and BLK2 is block 2. Each block can be a single statement, can be a whole sequence of statements, can be another type of statement, can be nested with all kinds of stuff in it, can be empty as well. Okay? So block 1 can be empty, block 2 can be empty. So when you see a statement that looks like this, with only block 1 and then an and if, it is the same thing as saying there's nothing to do for the else case. In other words, the second form, which is from line 7 to line 9, is the same as this. It's basically saying the same thing as if and only if the condition is true, we perform block 1, else there's nothing to do, and immediately followed by and if. So line 7 to 9 is functionally equivalent to line 11 to 14. Is that part okay? Yep.
So, is that what you mean? If if C, so it's not true. Like for example, if it's not.
For which part of the code are we talking about?
Like for line 7.
Okay, from line 7.
So we're tracing it out. So if we say if C is not true, so we're not going to do anything for it.
If C is not true when you trace it, then you go to the line right after the end if. You
So
skip
there
all
will
the
be
way
no
up.
else for that, so we won't do anything for
It is equivalent of having an else that has nothing to do. When you draw the picture, the way you would draw that picture is like this. Okay, this is a typical conditional statement. I'm going to draw a typical conditional statement where we have 2 branches, merge, and then we get out. I don't even bother to talk about the actual condition. If you want to equate this to the pseudocode on the whiteboard in the projector, this is condition C here. If it is true, we go to the then branch. If it is false, we go to the else branch, right? Now, if you do not see the else, like in the case of line 7 to line 9 on the projector, it is simply saying there's nothing to do here. If there's nothing to do there, it's just a path straight to the exit. It's the same thing. So functionally, they are equivalent. It's just that it's a shorthand to do it that way. Am I doing okay so far? Okay. So would that help? I mean, would that kind of solve the problem that was the issue here? In other words, if I just put an additional line here, we'll call this line 7.1, because I don't want to renumber the lines, right? If I put an else here all by itself, would that solve the problem that you guys were encountering?
No. So else is just separating it, right?
Else is separating the 2 parts of a conditional statement. You look at the if as an open parenthesis, you look at the end if as a closed parenthesis. you look at while as an open parenthesis, you look at and while as a closed parenthesis. So the question is, can you use those parentheses correctly in this case to know which part is included in which other part?
Yeah, I'm having a problem deciding what parentheses ends where. That's kind of.
Okay, how about this? I'm going to help you do your homework just a little bit here. While is open, if is open, if is open, don't mind the else here, the else is not as useful, and if is closed, and if is closed, and while is closed. Would that help?
Yes.
Okay, so that's basically how you need to look at it, is to look at if as an open of a statement and if as a close of that statement. While as the opening of a statement and while is the end of that statement. So would that help in terms of analyzing the structure of the program? Okay, there was a hand a little bit earlier. Go ahead.
I was gonna say, there's no more open or closed parentheses right now.
There are
Like,
no more.
You gave us all the open and closed parentheses.
Correct.
Like there wouldn't be any.
That's it. I mean, I marked every single line that starts with either a while or an if, and I marked every single line that starts with an end. So, yep.
So in a way, it'd be like if we're looking at a really long sentence, we should be able to kind of pick out the sections. Like
Correct.
If we just read.
Yep. Mm-hmm.
And when I indent, do I indent the whole? Say I was going for like a while and in while. Do I indent the whole thing or just those 2 lines?
The while and the end while stays with their own indentation, and then the content in between, is one indentation to the right hand side. But if that thing is inside another construct, then the entire thing has to be over as well. Okay, I'm pretty sure we talked about this, so I'm going to go over that again, so that we just want to take a look at this thing again. Okay, so we have seen this again. We have seen this already. It is the code to find the maximum of 3 variables, but only using traditional conditional statement without a multi-branch conditional statement. So let's go ahead and take a look at that one. If W is greater than X, then so inside here, I already know that W is already greater than X, so X cannot be the maximum. So that means the only contention is between W and Y. So I would say if W is also greater than Y, then Y, Z gets the value of W, because W is the maximum in this case, else Z would get the value of Y, because in that case Y is the maximum. And if else, now this else is starting the block where W is greater than X is false, which means X is greater than or equal to W. So in that case, the competition is between X and Y. So I would compare X with Y. If X is greater than Y, then X is the maximum. So Z gets the value of X, else Z gets the value of Y, and if. And that parenthesis should not be here. There you go. All right, so let's go ahead and apply the same technique here and see if we can do the indentations correctly and identify the structure of the code first. Okay? Are there any questions about this? How many people have a photographic memory and just completely remember what this code is supposed to look like? Good, because that would not be helpful. Well, there are people with photographic memory and still be able to kind of reason things out, and those are truly unique individuals. John von Neumann is one of those people. I think I talked about John von Neumann one time already, but he has both the intellectual capacity to reason things out and also a photographic memory, which is a very, very rare kind of thing. Okay, so let's take a look at this one first. And we said, if is open parenthesis, if is open parenthesis, don't worry about the else, okay? At least not that. And if is close, if is open, and if is close, and here's another close. Is that okay so far? I have just identified the beginning and the end of each construct and not even worry about how they are nested, which one is inside which other one. I just identify which one is open, which one is closed. Is that okay so far? Okay. So the next thing we need to do is to say, oh, you know what? I can see that this one is kind of on its own because there are no more nesting within this block here. Is that making any sense? There are no more open or closed parentheses from line 2 to line 6. Okay, there are no more if or while inside, so there's nothing nested inside. So the first thing I would do is to look at this block here and say, do we have any nesting here? Well, the answer is yes, because these two statements are nested within that conditional statement. So, so these two lines are the first ones that I need to do one indentation over to the right-hand side. I apply the same reasoning to line 8 to line 12. From line 8 to line 12, I look at this block of code and say, well, we don't see any additional ifs inside this block of code, but that also means that these two lines need to be indented because they are actually inside their assignment statements inside a conditional statement. Are we doing okay so far with this part? Okay. So the next thing that we need to do is to say, okay, now let's look at this entire block here, or look at the outer structure. This entire block is actually the then block of the outer conditional statement, because you can see the open parentheses of the outer block is here, and this is completely contained within that block. So this entire block needs to be indented once to the right-hand side as well. And the same thing applies to the other block, which is from here to here. The reason I know where they start is from here to here, the parentheses. So I increase the indentation of that, and I'm done. That's basically this particular program. Yep.
I had a question, because on the homework it says if z is less than 5, or z is less than 5, do this, but then the if is below that, it says x is less than 2, so it's kind of switching two variables like...
Okay, that's your homework. So which line are we talking about?
3 and 4.
Lines 3 and 4. Okay, line 3 it marks the beginning of a while loop. Line 4 marks the beginning of a conditional statement. So the question now is, how do they relate?
Correct.
Right? Well, where do you find the end of the while? Which line marks the end?
13.
Line 13. All right. So that means this conditional statement is, how does it relate to the while loop?
It's nested in it?
It's nested in it. Correct.
Okay. All right. That makes sense.
Can you go back to the example real quick?
Sure.
I just wanted to look at it.
Oh my god, this is so hard. We had like really cool homework and now I'm
Well, we're getting started with the 4th week of the semester. And this is just the beginning. Yep.
Alright, so say there's for the homework there's a while statement and there's in while. If so you if there's like an if right after it, you indent the whole thing, even if it says indent else another indent.
Okay, let me make sure that we can switch to the other slide first, and then we'll go take a look at that. Okay.
I'm good.
You good? Okay. So let's switch back to the homework assignment. Which part are you talking about?
The while, and it says if after it, but the end if is at 13 already, so do you indent the whole, since it's inside the whole thing? It's 2 parentheses. So
I'm missing one parenthesis, didn't I? I did miss one. That should be one here.
Yeah, so do you indent the whole, like, inside the whole parentheses, do you indent it?
Everything from, everything between the parentheses should be indented, with the exception of else. Else should have the same indentation as the if and the and if, but otherwise everything inside the if and the and if should be indented once to the right hand side.
I have a question about the indentation. On line 1, 2, 3, 4, and 5, they should be indented. Wait, is that 4 and 5? I think I missed something.
See, it's between 4 and 11.
Yeah.
Yeah, I wrote it down wrong.
Yep.
I don't know if you're going to answer this or not, but line 5, 7, 10, and 12 are supposed to be indented twice.
Okay, let me check. Line 5, 7, 10, and 12. Nope, they do not have the same indentation level.
Because line
There are two levels of indentation within these 4 lines.
5 and 7 goes 1, 2, 3 times.
Just 5.
You have to count the parentheses, okay? Count the parentheses, and that will tell you how many times they should be indented. Yep, go ahead.
Well, indented once it would be 4 to 8, and then indented twice it would be 6 to 11.
6 to 11. No. 6. Okay. The conditional start statement that starts with line 6. Where does it end?
It's 11.
Not 11.
8.
Line 8. Yep. Remember, you match it just like you match parentheses. And that's why we have column C using the parentheses to help you identify the beginning and the end of a construct. Yep.
It would be line 3 and 13 would be indented once, line 4 and 11 would be twice, and line 6 and 8 3 times.
What about this? I'll give you another example. Because I don't want to use the homework assignment to talk about it, I'll just go ahead and use another one. So we'll just have, a hypothetical algorithm which does not do anything that's usable or sensible or anything like that. Okay. So we have, condition C1 here, and then inside we have, let's say, a repeat loop here, and then inside the repeat loop we have another conditional statement. If C2, then we have, let's say I just call it statement 1, whatever statement it is, doesn't matter. We have an else here, and then we have another conditional statement. If C3, then something, statement 2, and if, and then we have statement 3, STMT3 here, and if again, and then we have STMT4, which is another statement here, until another condition, which is C4, else, and then over here, let's say we use while here, while C5, do if C5, then do something else, statement 5, and if statement 6, and while, and if. Okay. So I hope I can mentally track everything correctly, because that will be, otherwise it will be kind of a blunder here. Okay, so let's go ahead and do the indentation for this code. And obviously we cannot trace it, right? Because if we don't know what is C1 to C5, or statement 1 to statement 6, there's no way I can trace this algorithm. The only thing we can do with this one is to identify the correct indentation level, and also to draw a picture of the overall structure. There's no way I can draw this picture on the whiteboard and still have enough room and have it so that you guys can read the entire thing. Okay, this is kind of complicated. All right, so what we'll do is we'll do the same thing that we did before. Okay, in other words, when we see something that is the beginning of a construct, we just use the open parenthesis on one side. Okay, so open, 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 and then we have end if it's closed. And then we have end if it is closed until it's closed, because until closes a repeat. Okay. Else we don't really do anything about it. While is open, if is open, end if is closed, and while is closed, and end if is closed too. So the first thing I would do is to check that I have the same number of open parentheses and the same number of closed parentheses. So we have open, 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 close, 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 and then we have open, open, close, close, close. So we have, I need one more somewhere.
You didn't start the.
Oh, the repeat does not have one. The repeat, I missed one right here. The repeat is an open as well. You don't have to worry about repeat because you don't have repeat in your homework assignment, but repeat marks the beginning of a post-checking loop until marks the end of a post-checking loop, and that's why repeat opens and a until closes. Okay, so are we doing okay so far with column C, which is just identifying who is opening a construct and who's closing a construct? Okay, so we start with the innermost portion. In other words, we identify a block where inside the block there are no more open or closed parentheses. Can someone identify just one range of block like that? 6 to 8. Very good. Okay. So we focus on this block first, okay? And then we say, within here, do we need to do some indentation? And the answer is yes, okay? Because whatever is in between the open and the closed parentheses needs to be indented once so that we can say, this is the stuff nested inside whatever is enclosing it, okay? So in this case, we want to indent line 7, or row 7 in this case, and just use the indent tool here. Where's the other block? Okay, so I'm gonna highlight this just so that I know this block is already done, so this way I don't go back and redo something over and over again. Okay, where's the other block that we can, well,
15, 17.
Yep, 15 to 17 is the same way, because within this block from line 15 to line 17, there's only line 16. There are no more open or closed parentheses nested inside anymore, right? So that means I have to indent line 16, because line 16 is the statement embedded inside the conditional statement from line 15 to line 17. Is that okay? Okay. So we indent whatever is nested, but not the beginning or the end of whatever is the one that is enclosing. So we now indent this particular one, and then we use color highlighting to say that this is all done. You don't have to use color highlighting, because I use that just to remind myself which one is taken care of. Okay. So if those things are taken care of, the other thing that I might want to do is to remember, hey, you know what? These things are already done, so I don't really need these parentheses anymore. Okay, so I can delete those parentheses and say, okay, you know, we have taken care of this particular nesting. So now we try to identify the next level of parentheses. So can someone tell me which block has an open parenthesis and a closed parenthesis, but nothing like that in between?
3 to 10.
From line 3 to line 10, okay? From line 3 to line 10. So we'll go ahead and take a look from line 3 to line 10, okay? And that is because it is one single block, because it's a single conditional statement. Okay? Now, with a conditional statement, it's a little bit trickier than a loop, because a conditional statement has potentially has 2 blocks of code, because it has a then part, it has an else part as well. Okay? So with this one, you have to be a little bit more careful and say, okay, but which one is the then part? What is the line number range of the then portion of this conditional statement?
From 3 to 8. Or 3 to 7.
Remember, the else separates the then from the else.
4 to 9.
4 is by itself, is the then portion only of this conditional statement. Because when you look at this conditional statement, the beginning is here, the end is here, the separator is here. Okay? The if, else, and end if is the construct of a conditional statement. The else is only there to separate the then portion from the else portion. So that's why when you look at line 4, it is on its own. It is the only statement of the then portion of this conditional statement. And then everything else from line 6 all the way to line 9 is the else portion. And because these two are nested inside the conditional statement from line 3 to line 10, they need to be indented exactly once. And you can see that statement 2 is now indented twice, because it was indented once because it was inside the conditional statement from line 6 to line 8, but then from line 6 to line 9 is the else portion of another conditional statement. So that's why that particular line, which is line 7, is now indented twice. Yep.
Do you even indent the end if?
We do not indent end if, or else, or the if of that particular level. We only indent whatever it is containing.
Didn't you just, I get it, okay. So you just indented now 4 and then 6 through 9?
I indented line 4 because it is the then portion of this conditional statement. And then the other portion is from line 6 to line 9 because that's the else portion of the same construct. That is exactly right. So now I can do the same thing over here, okay, because the next level down here is from line 14 to line 19.
Wait,
okay?
did we highlight that and get rid of the?
Oh, okay, let's go ahead and do that.
Sorry.
So we'll go ahead and highlight it and get rid of the parentheses because we took care of that. Okay. So the next one is from line 14 to line 19 because line 14 has an open here, line 19 has a close here. So this range of statements is its own block. We do not indent line 14 nor line 19 because those are the beginning and the end of the construct, but we indent everything in between. In this case, it's easier because with a loop, you don't have the two blocks of a conditional statement. It only has one single block within. So that means we take a look at line 15 to line 18, which is the stuff inside the parentheses and the closed parentheses, and then we indent that entire block. And you can see that line 16 is now indented twice because it was indented once because it was inside a conditional statement, but that conditional statement turns out to be inside a while loop, and that's why the entire conditional statement is indented once, resulting in line 16 indented twice already at this point. Are we doing okay so far? Okay. Well, we're not quite done yet, because as long as you can still see parentheses in column C, we're not done. Okay, because we erase those parentheses as we make progress through this thing. Okay, the next level is a rather big block here, because this is the open, this is the close, and in between everything do not have open or closed parentheses. Yep.
Don't you erase the 14 in line 19 parentheses?
Say again?
Line 14 and 19 parentheses.
You can go line.
Supposed to erase it by now?
Sorry?
You didn't
supposed to erase
highlight.
Oh, right. Yep, you're correct. I forgot to do that. There we go. Erase and highlight. The highlighting part is really kind of nice because it gives you the satisfaction of, hey, it's almost the whole thing now, right? The yellow portion is getting bigger and bigger. Cool. Okay, so now the next portion is from line 2 to line 12, right? Because line 2 has an open parenthesis, line 12 has a closed parenthesis, and we don't have any additional parentheses in between because we erased all of those because we took care of all of those already. Okay, now with a repeat until, it is the same as a while do or while block. It only has one single block instead of having two blocks like a if, else, and if. So in this case, we just take whatever is in between the open parenthesis and the closed parenthesis and say everything from line 3 to line 11 are nested inside the repeat until loop here, and so they will all get indented once.
Wait, so can you do that again? I'm sorry. Why don't we do that then in the if and the then?
Why? Because the repeat and the until lines, line 2 and line 12, are the markers to mark the beginning and the end of the entire block. We do not indent the beginning or the end.
Right, no, I get that, but you know how like inside we did the else as being the true part of this statement, and then
Right.
so we don't do that because what?
We don't
This time?
do.
Oh my god. Okay, I'm sorry, I can't
Or
trick
if it
it
gets to the
myself.
time, you don't indent them. That's what she
You did after.
What?
You did after open parentheses and before closed.
I only
Right.
indent the content between the open and the closed parentheses.
Right, I get that, but how come you don't separate it by the else again? That's what I'm asking.
Because the else is already taken care of. The
Okay.
else is a part
Of
of
the
the
different
if and the
statement.
end if.
Okay.
So we
you
took
don't-
care of that already.
You don't have to redo it.
Correct.
Okay.
Because the else belongs to the conditional statement, which is from line 3 to line 10, and we took care of that already. So we don't have to pay special attention to the else anymore. This entire block is considered one single block now. Yep.
Yeah, basically when you color code it like this, anything that has a yellow you don't worry about anymore.
Exactly.
Because you just move the whole block as a whole.
Yep. The entire block is, we don't even look into that block to see what is inside that block. Whatever is already colored yellow, it's just say, well, it's done already. We don't need to look into that block anymore. Okay. All right, so this entire block will indent it once. And then we take care of these parentheses and also highlight that portion yellow as well. So we take care of the parentheses and we highlight it. There we go. And wow, we're almost done, right? We only have one open parenthesis left on line 1 and one closed parenthesis left on line 20. But this open parenthesis is corresponding to an if, so we have to be careful to identify the else, because the else and the if and the and if, they all have to belong to one single level of indentation. So, but whatever is already in yellow that is highlighted is considered one single block. We see the else is here, so we just have to identify the other part, which is the else branch. Select all those cells. Using control click, you can select individual cells and add it to the collection. And then we indent this entire block one more time. This is now taken care of. And change the highlight. Now we got the whole thing done. So do we have any questions about this part? No? Let me just check the recorder, make sure it's still recording, right? Because I have a feeling that some people might want to go over this again. Yep, it is recording, you know, the voice is good, so.
Can I take a look at the homework one more time?
Absolutely. There you go. Go ahead.
My question was about the homework. Like, if the line 3 is true, then we jump in into another parenthesis? Or
If
because
line-
in math, we kind of look what parenthesis we work on first.
Okay, tell you what, I'm gonna split this homework assignment into 2 parts, okay? No, it's not adding any more work. It's just, you know, you have a little bit more time, okay? So on next Tuesday, only the indentation part is due. You don't have to trace it. Do not trace it, okay? If you want to trace it, that's fine, but I'm not gonna grade it, you know, grade the tracing part. So on Tuesday, turn it in just like you would normally turn it in, but do not trace it. Just turn in the version that has the indentation first. Yes?
Will you, when you grade it, let us know like what we did wrong on it? That
Okay.
Way, that way we know when we trace it if we're looking at it the right way.
Right. So what I'm going to do on Tuesday, next Tuesday, is the first thing in class, you know, is I will give you the solution to the indentation part. So once you have the indentation part, you can compare, you know, my solution to your solution, okay? You know, because I will give you the actual solution, right? So you can compare and see, you know, how are they different? If they are different, you know, then you have to kind of identify why are they different. Yep.
Can we add the 7.1 line in on our homework, or will that get wrong?
No, you can add it. It just doesn't do anything. I mean, it's just, you know, identifying that there's nothing to do in the else portion. But it should not affect the indentation structure at all. Yep. All right. So is that okay? I mean, you know, just, you know, on Tuesday you turn in the structure, which is the same code but with indentation. I'll give you the solution to the indentation part on Tuesday, and then on Thursday you will turn in the actual trace. Yep.
Oh no, I was just clicking my pen, sorry.
Okay. For those of you who really want to, you know, kind of get more, you know, exercise, you can still do the tracing part. It's just that I'm not going to grade it on Tuesday, and you can turn it in again on Thursday. Okay, but I would still encourage you guys to try to trace it. You know, if you think that you got the right structure, go ahead and trace it using that structure first. Okay, and if you run up against the wall, okay, you know, you can just stop the trace because I'm not going to grade the tracing part on Tuesday. But I will give you the solution to the structure part so that you can actually do the tracing after that. Yep.
Trace for this will be relatively long, right?
No, it's not going to be a very long trace. The outer loop goes through, I cannot remember how many iterations, but not a whole lot. Maybe 3 or 4 times at the most. Any other questions? No questions? Yep, go ahead.
We don't have to intent in the particular way that you described. I mean, what just go line by line.
What do you mean by go line by line?
Like the way I intend, You know,
You just
go,
put space next to it?
basically just, once you reach a certain, like you go line 1, then go line 2, okay, line 3. Line 4 is inside the first loop, so you indent them once.
Oh, you can do it
Everything
any
after
way you
that,
want. Yeah, you can do it any way you want. It's just that visually it has to resemble the correct indentation. Yeah, some people can do it line by line, you know, from the first line to the last line. They just analyze the whole thing and do the indentation levels that way. That's okay with me. Yep.
If it's while, then I know that I'm gonna be repeating.
A while loop
Is
is
a
a
loop?
loop, yes.
Okay.
And that's why I finished grading the while homework assignment already. Okay, so if you check your homework assignment for the while homework assignment, you can see whether you did that one correctly or not. So that's good because that means when you're tracing this code, you know exactly what I'm expecting.
So we just go where we submitted it and it'll say our grade?
Correct. That will
Okay.
say your grade. You can also go to the grade book, but the grade book is kind of messy right now because I haven't really cleaned it up yet. So if you go back just to the homework assignment, it will give you the score, and it's rubric based, so you can actually see, where if you lose any points, you can see where you lose the points.
Okay.
Is there any way to check the overall grade? 'Cause
The overall grade right now is just a big mess, so I wouldn't worry too much about the overall grade. If you just look at your homework assignment, that should give you an idea of how you're doing in class. Yep.
I actually had a question about that, because I got an email stating that you had a statement on it, and it says I have a 0 for one of the homework assignments for the last one, but I have an email showing that I submitted it. So how do we fix that?
Okay, you have an email showing me that you submitted it.
Yeah, it's the what do you call it, email?
Oh, so there's a
submitted-
confirmation from Moodle that you turn it
yeah,
in?
I submitted it.
Okay, that's interesting because I just grade based on what Moodle shows me, whether there's a file to grade. So go ahead and send me an email, with your name and cisp300 9 o'clock section, and then I'll go take a look.
Okay.
Mhm. Right. Any other questions regarding the homework assignment?
Thank you.
The homework? This is okay? Row sheet? I forgot the row sheet, so I'm not taking row today. And it does look like today would be a good day to take row. That's okay. I'm okay with that. All right. So that's your homework assignment. I hope this process kind of helps. It's not the only way to do it. I mean, this is one way that you can do it. Once you get used to this sort of thing, you can probably do it mentally. In other words, you just look at the code and go, and get it all done. But this is not a bad start. Okay, it's just getting started. It's a little bit harder. And the homework assignment, this is the first time I assign a homework assignment that has this part of it. I give you unindented code, and you guys have to do the indentation. So it's the first time for me to assign this type of homework assignment, which I think is kind of interesting too, because it really helps me understand that the structure of the program is more important than I thought it was as a topic in this class. Because I thought, oh, okay, everybody got this part already, how a construct can be inside another construct, and it's good feedback that you guys just gave me that I should not make that assumption. Yep, which is fine. I mean, that's not an issue at all. That's why I'm here. I'm teaching, right? Well, that kind of brings up a question that has nothing to do with algorithms and whatnot. How do you guys like online classes for those of you who have taken online classes?
I like it.
You like it?
I actually had this class as an online class, but I dropped it to come inside. I don't think I would have been able to get it.
If it is a fully online class.
Unless we can watch your lectures, because some teachers don't watch it. I would just have to read your notes. I don't
Right.
think I would have
But what if you have a good textbook?
Oh yeah, well see, I don't know what the textbook is like either.
Okay.
But I do like online classes. I take 4 now. So.
Mm-hmm. Go ahead.
I've had one or two, but I quickly found out that I just can't do online classes, period, because I need the interaction. I need to get questions and answers live. I learn through hearing and doing equally. So if I'm not interacting with the lecturer and getting questions from people around me, I don't learn almost half of what I would get from textbook or from just reading.
Okay, so I'll save a question that I have, and I'll, let you guys go talk about it first. Go ahead.
Oh, mainly it's just like when you're in a lecture, if something comes up,
Right.
you raise your hand and ask a question. Online, you can't do that.
Assuming I do not ignore all those hands that are waving, right?
Yeah, it's hard. I mean, you can have the best textbook, but like me, there's certain things I just can't grasp
Okay.
in class.
That just prompts me for a question that I'll ask you later. Go ahead. No, okay, go ahead.
I loved online classes, but I also like to learn on my own too, though. I think it also depends on what kind of person you are. There are some people that need more interaction, and I didn't even have a textbook for that class. It was more like project-based, and I really
Okay.
like stuff like that. So.
Okay. Okay, so here's the next question, based on your feedback, is there a way to turn online classes more interactive so that it resembles a face-to-face class closer? It accomplishes the same thing. What do you guys think?
Yeah.
Okay.
It was interactive, yeah.
More interactive?
Yeah, if you could ask a question, they could answer it in real time.
In real time. Okay, so that's one thing, is to being able to ask questions and have the professor to answer questions in real
Then
time.
what's the point of having an online class then?
Yeah, I don't know.
You know, if the teacher's still there, like while the class is in session, answering questions, then what's the point of having the class online?
And then you have the pressure on due dates,
Okay,
like,
so now-
you have to be there.
The teacher could be Watson.
The teacher can be Watson. I like that. Dr. Watson, Professor Watson. Yeah. Okay, go ahead.
And it could also be while you're doing your class, you don't have to be in school. That's another
Right.
thing. You could be in your, like, you have an office at home. Most of us might not, but if you have an office at home, you can be doing your work while also the instructor has a little section, his homework, whatever.
Right.
Where he can do the same thing you do in class.
Okay.
Sometimes maybe more beneficial on what the instructor may have.
But it may not, but that makes it harder to make the class interactive like in a regular class.
So, I mean, that's kind of weird.
But that would assume that professor will be in office during a certain time, and you guys will check in during that exact time frame as well. Yep, go ahead.
Yeah, that was my point, was that some online classes, my professors have office hours, online office hours, that they'll be there, but that's assuming that I can do it at 1 o'clock, and sometimes I need to do it at 6 o'clock, and then they won't be there, but they're pretty good about answering within 24 hours, I think. So.
But 24 hours is still a relatively long time compared to how long it takes for me to answer your question in class, right?
Yeah, but if you have your assignment ahead of time and you procrastinate and now you don't have that 24 hours, it's not really your teacher's fault.
That is true. That is true. That was in. Go ahead.
So, some services like Ustream or things like that, you can have that interaction. And I wouldn't do it for like lecturing on stuff, but maybe a small time period for Q&A. So you're not lecturing with live stream, but you're just answering questions live, maybe once or twice a week or something like that. So that's not a requirement for students to go there, because that's kind of the point of them taking online classes, is to get away from having a set time, but there might be a time that you could go. So
Okay.
that might be cool.
All right. Thank you.
But yeah, like Twitch, you could live stream it and they could ask questions in the chat of you, like in real time, so there wouldn't be an issue there.
Yeah, Moodle actually has a chat, has its own chat engine where you can log in and I can log in, and any people can log in within that class, and you can. It's kind of like a chat engine, but at the same time it has a virtual whiteboard, so we can all draw stuff on the whiteboard and stuff like that. Yep.
I was gonna say, it would be kind of the transition to online would be the hybrid classes, right? Where you have.
Right, the hybrid class has quote unquote the advantages of both, but it also has the disadvantages of both also. Because you still have to come in during the face-to-face portion, and then you still have the online portion. I'm asking these questions because I'm on the distance education subcommittee of the curriculum committee of ARC. So my job, or at least a part of my job, is to currently is to draft a policy that will basically form the basis of what is the minimum contact of an online class between the professor and students. So that's basically why I'm asking these questions. Yep.
Well, like she was saying, some people really do learn very well on their own, and some need more interaction. But I would say for classes like these that are foundational and have such dense topics that are really supposed to be for brand new people that don't understand or haven't heard anything about these. I don't think that that works very well as an online class because you need this constant interaction, these questions. But for something later on in the program, like maybe even 360 could do it, or some where you've already got some programming under your belt, or another English class, you could do that kind of thing for other higher level ones. But
About knowing yourself. You just have to know yourself.
yeah.
But what I'm hearing from you guys, is the live interaction part is important. Even for online classes, some people prefer to have that live interaction capability instead of just asynchronous communication, which is okay, you post something or you email something and then you wait for the response.
I was gonna say, well, one thing with the online class that may be helpful is the live one-on-one with the instructor, through like Skype, for example, something where the student could ask a certain question through online rather than having kind of office hours.
Okay,
For the
but you're
online,
talking
that
about the
might-
virtual office hour more so than
Yeah, they're not
how a
physical.
class is conducted.
Yeah.
Yeah.
When it's an online class,
Right.
that might be beneficial.
Okay, go ahead.
I just have I don't know. I guess my thing about the online class is that sometimes I feel like their syllabus is like, if I have a question, I don't know. I have online classes that I've been able to go to an orientation on site, and then the rest of the class for the rest of the semester was online, besides I think the final was in person too. I think that was helpful to go over the syllabus with the teacher and really know what they expect, because sometimes there's a gray area online. And
I think
so-
there's a more of a variation, or the spectrum is wider when it comes to online classes as opposed to face-to-face classes.
Right.
Yeah, I think for face-to-face classes, I think most of us know what to expect. Yep.
I haven't taken it music class, and it's point based, so we have all our assignments, and he just says do any assignment you want. When you get 9,000 points, you have an A. Tell me when you want to be done with the class, and then that's it. So if you get 8,000, you got to be 7,000, you got to C. I kind of like that online class because it's self-paced. I can do it all today, or I can spread it out. There's no due dates, and then it's not it's just what I learned. So if I mess up on this assignment, then I have another assignment. So
I see.
kind of like the way that is.
Okay, because with a face-to-face class, it's harder to be self-paced, right? Because the whole class goes at one pace.
Not exactly. There's an online textbook, and I just read it, take the course by self-paced, and it doesn't matter. I can just go take another one. Or
Right.
take it.
So now we are getting back to that really kind of thicker topic of how to derive the pre and post conditions. Remember, that's kind of where we left off. So what I'll do today is we have about 20 minutes, so that's enough time to to finish it today. All right. So what I'm doing right now is I'm just retyping the entire thing. But thank you so much for the feedback. That's really helpful. It's helpful that I'm not just kind of thinking, oh, let me think about what a student how a student may see online classes as opposed to face-to-face. It's good to actually hear from you guys. Okay, so let me turn off the line number of the editor itself because it's actually just interfering in this case. So I'm going to turn off line numbers. Okay, there we go. All right. So we have this code that we have seen over and over and over again. But this time when we look at this code, we are not going to trace it anymore. We'll try to derive the pre and post conditions of some of these lines and try to come up with a conclusion of, okay, so what exactly is guaranteed when this algorithm completes, even not knowing anything about the exact value of x or the value of y. Okay, so that's what we want to do. On the other day, we basically said pre1 is true because we want to know something that has to be true before line 1 executes. That's the precondition of line 1, or pre1 in parentheses. So if I don't know a single thing about x, a single thing about y, or a single thing about z, what can I say that is true? Well, it's true itself. Okay, so the precondition being true on line 1 simply says I don't know anything about the variables. I do not make any assumptions about the values of these variables. So x can have any value, y can have any value. That's the precondition of line 1. The next line I deal with is line 2. Okay, the precondition of line 2 is basically asking what has to be true immediately prior to the execution of line 2. In other words, I have already decided to take one branch instead of the other one. And right before I execute line 2, what do I know for sure? And on the other day, we already covered this part here. Whatever we state in pre-1 still has to be true because it's just one comparison on line 1 that will divert me to this branch. And the comparison is not going to change the value of any variable. So that's why, whatever was true before still has to be true at this point. But on top of that, we also know something else, because we also know the condition of the conditional statement also has to be true, because otherwise we would not be here about to execute line 2. We're doing okay so far with the precondition of line 2. And I think that's where we stopped last time. We kind of went through the simplification too.
Because we posted 2 also.
Oh, I did? Okay.
Yeah.
So it's true and x is greater than y because pre1 is true, and then we can simplify true and whatever to just whatever. And then with post 2, we know that x is greater than y still has to be true because it is not changing x or y. It is just copying the value of x to z. Well, that's handy because that also means that now we know z has the same value of x. Is that okay? I think that's where we stopped on the other day. So now we can go to the other branch and say, okay, if I'm just about to execute line 4, what do we know for sure? Well, pre1 still has to be true because that's just the other branch. A single comparison on line 1 will divert me to line 4 if the condition is false. So that means right before I execute line 4, the condition that was true on line 1 still has to be true because I didn't have a chance to change anything yet up to this point. On top of that, we also know something else because we know it is not the case that x is greater than y because otherwise I would not be taking the else branch. So now we can take this and simplify a little bit here. Pre1 is just true. And it is not the case that x is greater than y, it's just saying x is less than or equal to y. Is that okay so far? Does everybody see why the negation of x is greater than y is the same thing as saying x is less than or equal to y? Yeah.
I assume we were going to have to do something like this ourselves, right?
Yes.
And can we skip this step, that not x is less greater than y, or can we just go directly to x is less than y?
I would put it there just so that you can relate this condition to the conditional statement itself. Right? So every step has a purpose, right? I'm not skipping some steps, just so that I can make connection to every single thing, and I don't, accidentally do something. Okay, now we can simplify this to x is just less than or equal to y because true and whatever is just the whatever part. Okay, and post 4 is about the same as post 2. Because the condition or the relationship between x and y is still maintained because line 4 doesn't do a single thing to x or y, but it does do something to z. Z now has the same value as y after line 4 executes. So now we can say for sure that z has the same value as y. Yep, go ahead.
And couldn't you say potentially the same value as x? Since x and y can be equal.
That's a good question. But that is already defined by these two statements together.
Okay.
So when you say x is less than or equal to y and z equals to y, that also means that x can equal to z, even though it is guaranteed that z equals to y.
Okay.
Yep. All right. So now we have post 2, we have post 4. The question now is, what is post 5? In other words, what do I know for sure when the entire conditional statement is done? That really is the big question, and that's something that we did not go over on Tuesday. I'm going to kind of modify this picture just a little bit so that it represents a conditional statement, a typical conditional statement again, okay, like this. post 2 is what we know at this part. Post 4 is what we know at this part. Post 5 is what can we conclude at this point. Okay. Well, it's after the merging of the two branches, right? So what you can imagine is Tech is here, holding a bottle of hard liquor. Okay? And I just woke up here not knowing how I got here. Okay? And I know that these two are one-way streets. So I know that I cannot be coming from below because it's a one-way street. It can only go in this direction. I'm standing here dazed and go like, how did I get here? And what's under my hand? I have no idea. You know. Okay, so now the question is, well, but I can look back and say, hey, there's a label here. Okay, that's post 2. And there's another label here. It's called post 4. But I have no idea which path I took to get here. What can I know for sure when I'm standing here?
You took one of the two paths?
I took one of the two paths. But in terms of the conditions, how do I state that condition that has to be true when I'm standing here?
So, t is greater than equal to x and t is greater than y?
The value of z is changed?
How do I combine these two? How about that? I know it has something to do with post 2. I know it has something to do with post 4. I just don't know how to get those two combined.
That maybe z equals x or z equals y.
Okay, let's focus on post 2 and post 2 and post 4. Okay, how do I combine post 2, post 4 to become post 5? That is the question.
X and y are different.
Okay, remember, use just post 2 and post 4. Don't look into the content of post 2 or post 4. If I just say post 2 is here, post 4 is here, this is where I'm standing, what is the condition that has to be true?
X is greater than y and z equals x, or x is less than or equal to y and z equals y.
Okay, you guys are kind of... I probably did not ask the question properly. Okay, the question was, how do I use post 2 and post 4 to combine them into post 5? Okay, because this is general. Okay, this has nothing to do with this particular conditional statement. This is universal. Okay, whenever you have a conditional statement, this is how you combine the post conditions of each branch and form the post condition of the entire conditional statement. It is a simple OR. It's a simple OR.
You can just put post 2 or post 4.
Well, that's, then we can expand it because we know what post 2 is, we know what post 4 is, then we can actually combine them. But this line here, let me just highlight the line that I'm talking about. This line here is because of the structure of a conditional statement. It is not because of this specific conditional statement. Any conditional statements will have this property. You just combine the post conditions of each branch, and that becomes the post condition of the entire conditional statement. In other words, I just woke up here, drunk, and I did not know which way I came from, but one thing I know for sure is this condition or this condition has to be true. Now, note that I did not use either or. Go ahead.
So you're saying the post condition of 2 and 4 would have to be z is equal to x or y?
No, this has nothing to do with post 2 or post 4 itself. Okay, so I don't really care what post 2 is at this point. I don't care what post 4 is at this point. My focus is post 5. Okay, if I know what is post 2, if I know what is post 4, what is post 5? Then post 5 is a disjunction of those two conditions. Now the next step is to expand it and make a big mess out of this whole thing. But before I make a big mess out of the whole thing, I just want to talk about something that's relatively clean and it has to do with the structure of a conditional statement. Now note that I did not use either or. Now there's a reason why there's no either or. Because in certain conditional statements, post 2 and post 4 can be true at the same time. Either or implies only one can be true at a time.
Well, like when x and y are equal, then post 4 and post 2 would be both true, right?
Not in this case.
No.
Not in this case. But there are certain conditional statements where post 2 post 4 can both be true when the branches merge. Okay, so now that we know how to relate post 2 and post 4 to become post 5, we can just go ahead and, this is the typical way of doing things that I do, because I know this is a disjunction, but post 2 is kind of a mess itself, which is this chunk here, and post 4 is its own kind of mess, which is this chunk here. So let me just make the editor wider so we can see the entire thing. All right, so that becomes post 5. In other words, not knowing anything before the entire algorithm starts, not knowing the value of x, not knowing the value of y, not knowing the value of z, I can now make a conclusion and say, when this algorithm is done, this condition is guaranteed. I think that's a pretty, good thing to do. I mean, we can now make a conclusion out of assuming nothing whatsoever, and just by analyzing the algorithm itself, we can come to this conclusion. But that's only the first part of verifying an algorithm, because now the question is that what we want the algorithm to accomplish? In other words, let me scroll up the screen here so that we cannot look at this. Some of you have written notes already, so you know what it is. Okay, so the question is, if I say that z is the maximum of x and y, how can I express this, but only using comparisons and our logical operators? That's the question. It's a shorthand. I mean, this is a really nice and easy shorthand to say that z is the maximum of x and y, but how do we make use of only comparisons and logical operators to say exactly the same thing? Go ahead.
Z is greater than or equal to x, and z is greater than or equal to y.
All right. Z is greater than or equal to x, and z is greater than or equal to y, but that really is not the definition of maximum. Okay, let's think of a scenario. Let's say x is 0, y is 1. I can make z 10 billion, and it will still meet these two requirements, right? So we are missing something that's important about the maximum of two variables.
Comparing the variables.
Sorry?
Comparing the variables to see which one's larger than the other. So if you just say that z is greater than or equal to x, like you were saying, you can put whatever number in there, but you have to compare x and y before you can set z.
I can skip that portion, but I cannot skip this portion. This portion has to do with z has to be the same as one of them. Is that making any sense? In other words, this part is stating, okay, z is greater than or equal to x. Well, that's easy. Z is greater than or equal to y. That's easy too. But you know what? I have another constraint here. It has to be at least the same as one of them. Because x and y can be the same. Okay, so if x and y are the same, then z equals to both of them. But it has to be equal to at least one of them, and still be greater than or equal to every single one of them. Is that making any sense? Okay, so now we take this part here, and then we say, well, this doesn't look like that, right? I mean, this is the conclusion. This is the actual post condition of the algorithm. Is that really saying the same thing as this? They don't look the same to me. So are they actually the same? Does one imply the other? Okay, I don't really need them to be equivalent. Okay, if I can just say, for whatever reason, I can establish this condition implies this condition, I'm home free. Okay, I have just proven the algorithm will work regardless of the value of x and the value of y. Some of you will look at this and say, intuitively, it makes sense. Okay, one condition implies the other. But that's not good enough, right? Because if even though intuitively it makes sense, it does not always mean it actually does make sense. I'm not going to have enough time to go through the entire proof today, so I'm going to defer the proof to Tuesday. But I will use the remaining 5 minutes or so to talk about a story where it is, it's a story where I can demonstrate the importance of step-by-step rigorous proof in computer science. Okay, This is back in my dissertation days, when I was a graduate student at UC Davis. I was working on my dissertation, and my advisor told me, hey, you know what, Tech, you can start with this, okay? And this being a theorem that was supposedly proven already, and it describes a certain property of something that I was working on. Okay, so my advisor said, okay, you can start with this and go forward with your research. I did that for a few weeks, and then on one day I just thought, this doesn't feel right. It just doesn't feel that it's true in general. So I went back to my advisor and asked him, well, are we quite sure that this is proven? Okay, because I haven't found any proof, step-by-step proofs for this particular theorem. My advisor said, well, it was in somebody else's thesis, one of his other students, and he said, well, it's already done, so go ahead and just make use of the theorem. I decided not to. I decided to actually dig up the thesis, the master's thesis, and look through the master's thesis for the actual proof of that theorem, and I couldn't find it. There was a paragraph that says about blah 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 blah, and then there's the really usually considered famous last word in research paper. Obviously, and then here's the conclusion, the theorem that I was supposed to use. So there was no rigorous proof whatsoever. Okay, I could not find it in the thesis. I did not feel, that didn't feel right. Okay, so I went back to my advisor and say, well, that's not a proof. It's just saying that these things should lead to this conclusion, but there was no step-by-step proof that to make the connections. So I went back and, not to my advisor, after I met with my advisor, I went back and tried to find a counterexample. And I spent a whole week doing that, but I found one. I was able to construct one case to show that the theorem was not true in general. I went back to my advisor looked at my counterexample and go like, oh, that was the only feedback. was a oh, okay. So I went back to the computer lab to meet with my other lab mates, and one of them was working on about the same thing, and he was also using that theorem as a basis of his own thesis. And I told him, well, you know what, I found that this theorem was not true. Okay, I found a counterexample, and he just went ballistic. Because unlike me, I was only a few weeks into my dissertation, and that typically will take about a year and a half. Okay, so it's not like a big waste of time. He was almost done with his master's thesis. So he was not happy about that. And that's the reason why I cannot skip steps. Okay, I do not skip steps myself. In class when I prove a theorem, because I can make a mistake. If I skip steps, then I would not be able to realize that I have just made a mistake. It's not spelled out or clear to me, that I just made a mistake in a proof. Okay, so that's why in this class, you will see that to prove something like this, I will go through all of the steps. Okay, to make all of the connections. And this is also one thing that's about math, how math is related to computer science, is with math, you wouldn't skip a step in a proof to establish a conclusion, and you should not do the same thing with computer science when you're writing programs. So we'll come back and look at this again. We'll talk about the distributive properties of Boolean algebra when we come back on Tuesday.
I have a question.
This is
Yeah.